Welcome back, folks. Today we're going to have a look at this little FG100 DDS function generator that we picked up from AliExpress. Let's go over the specifications here. They talk about it. So the output waveforms, you got sine wave, square wave, triangle wave, forward sawtooth, and reverse sawtooth. The power supply is from 4 to 10 volts, and they say it's recommended to choose 5 volts when using the adapter and 3.7 volts lithium battery when using battery power. The current is 250 milliamps when the voltage is 5 volts. The frequency range, sine wave from 1 hertz to 500 kilohertz, and they put in brackets or parentheses, the output amplitude will decrease with the further increase of frequency. So I guess that 500 kilohertz is not really the 3 dB point, it's what the thing can squeak out. Okay, well, we'll have a look at that. Other waveforms are from 1 hertz to 50 kilohertz, but the upper limit of adjustable frequency is not limited. If the distortion and shaking requirements are not high, the frequency can be further increased. Not great English, but I get what they're saying. The resolution is 1 hertz. Sine wave distortion is less than 1% below 1 kilohertz and less than 0.5% above 1 kilohertz. Okay. Output amplitude is maximum plus or minus 10 volts peak to peak. Output impedance is 50 ohms. In DC offset, maximum plus 10 volts with shutdown function. Now that I don't quite understand, but we'll twiddle that offset knob and see what it does. All setting parameters can be saved, but they don't tell you how. There are filters that can be turned on and off, which can be well adapted to sine and pulse waveform output. Is that them? Okay. And it goes in, does a little bit of marketing blurb here about compact size, and it can be run off a 3.7 volt lithium battery. And together with an oscilloscope, it can be used for electronic circuit test and debugging, frequency characteristics and impulse response test, and measuring of audio amplifiers. Due to the good accuracy and frequency stability of DDS, it is also very suitable for oscilloscope sweep time factor calibration. The square wave output is suitable for oscilloscope attenuator and probe pulse characteristic adjustments. Really, that's saying quite a bit, so it must be like in a 1 nanosecond rise time. We'll have a look. The mode button is used to switch the waveform. The cursor is used to stabilize the cursor, adjust the frequency with the plus minus key, run, stop, run or stop the output wave. When the cursor does not flash, the waveform is output and other keys are invalid. Plus is frequency plus and minus is frequency minus. Alright, that's all it says. That's it. Okay, so all it came with was just this. It's itself and this little USB cable. And I'm going to take that up. I'm going to use that with a genuine Apple adapter here. Note here that this is not really a standard size DC plug, so that's a little annoying because I could have used other cables if it was. Okay, so it's not plugged in, and let's just turn it on, see what happens. There we go. Okay, well, they say it's 50 ohm output, so I'm going to put it into my scope here with one of these. That's a 50 ohm terminator at the end. To give it its best shot, but I have my doubts it'll be able to maintain 10 volts peak to peak with the terminator on it, but we'll see. The scope's all turned on and ready to go. Okay, so that's 100 kilohertz, and we got our maximum here. So, ooh, that doesn't like that. So that's with the DC offset off, we're getting this particular waveform. So far, I honestly say I'm not terribly impressed. Okay, that's just awful. Okay, so then we adjust the offset, so we're kind of look at that crossover distortion. Holy, what are they using for operational amplifiers in here? Worn out tubes or something? Okay, so we're at maximum amplitude. No, we're not. So we get a better. There's no calibration whatsoever on the amplitude. It's just a knob, you turn it. So we're turning it up past that. We don't get any more. If I could get less, this looks like it's the kind of the most we can get out of it. And we're getting what are we there? We're at 200 millivolts per division. So we're getting about 600, 700 millivolts peak to peak. Nothing near the 10 volts they were promising. All right, so let's maybe we could bring the frequency down a little bit. So let's see how that works. So we have to stop it. The cursor's blinking, and then we. Okay. Okay. So let's try it at 10 kilohertz. Let's bring down that amplitude. And we'll change our time base a bit. That's not a pretty looking waveform. This is, I think the word that's coming to my mind is atrocious. Let's see if I can adjust the offset here a little bit before we bring down the amplitude. Maybe they're switching the output with relays or something. This is horrible. We're on the 500 millivolt range there, and we're getting about looks about 3 volts peak to peak. Okay, so let's look at square wave here. Mode square. So square wave at 10 kilohertz. Are they serious? You could do bandwidth measurements with this? No, I don't think so. Let's increase the frequency. See when this square wave looks. See what the square wave looks like when it's a little bit higher. So let's try 50 kilohertz. Okay, so let's bring it down. Let's go down into the 1 kilohertz. We'll try 1 kilohertz. See if that can manage that. All right, stop. Cursor over. Minus, 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 minus. Cursor over. Plus. 1 kilohertz. Okay. All right then. Adjust our time base. What about the filter? What will that do? So let's take the 50 ohm load off it, see if that will improve things. It'll probably improve the output voltage for sure. Okay, well that's a lot better. So indeed it doesn't have a 50 ohm output. It has a high impedance output. All right, and filter gets rid of that. So okay, that's better. I say it's good. We'll change the trigger to a falling trigger, and we'll have a look at that crossover distortion a little bit. So that really hasn't improved. It's just that at higher frequencies, it's the dominant factor. But even at lower frequencies here, you can still see that. So let's try the sine wave again. A little bit less evident there, but you can still see it. Okay, is that supposed to be 1% or less distortion? No, they're out of their minds. Okay, so now without the 50 ohm load put on it, it looks like we're getting. We'll increase the amplitude here to its maximum. If it stays even slightly sinusoidal, there we go. So okay, we are getting plus or minus, so 20 volts peak to peak, plus or minus 10 volts. So that part is true, at least at a 1 kilohertz. Let's pump it up to 5 kilohertz to see what happens there. Oh, it's still looking half decent. Oh no. that crossover distortion is now becoming a factor. I mean, you would actually, if you put that through an amplifier, you would hear that. That would sound nasty. Okay, let's get it up to 10 kilohertz. The user interface is a little clunky, but it's workable. Okay, we'll go up to, we'll try 9. That is not a sine wave. With or without the filter. With or without adjustment of the offset. That's turned into a really bad triangle wave. Let's see what the triangle wave looks like then. Almost exactly the same. Okay, let's look at the next one. Sawtooth. Yeah, that back end should be almost vertical. Reverse sawtooth. Really, really awful. Absolutely awful. I mean, I don't know what to do with this thing. Like it just try it down at 100 hertz and cursor over and 100 hertz. Let's adjust our tie base accordingly. Okay, now that looks like a fairly reasonable sawtooth, but I mean, the rise time on this thing is so bad. You have to be down at 100 hertz before it even looks like a sawtooth. So yeah, so let's look at the sine wave at this frequency too. Again, you know, it's passable. Okay, well, okay, this is just probably, I would have to classify this as quite possibly the worst instrument I've ever had a look at. I mean, this is, unless you're only interested in frequencies 1 kilohertz or lower, technically useless. Now, there's something else I did notice about as well. Let's pull it apart, but I want to show you. So I'm going to turn the power off and disconnect everything. So no point in watching that anymore. Now, listen to this. I don't think things should be rattling around inside it. I may be wrong, but let's flip our little box over here and give me a little bit of room to start tearing into this thing. 4 screws on the back here appear to be the ones to let you in. I did do a little bit of research on this before I purchased it, and it seems, you know, there's not a lot out there that gives you real good information, but it seems that you either get one that meets its specifications fairly well, or you get a piece of crap like this. And I just happened to get the piece of crap. Okay. Very, very, very long little tactile switches in there. And we got a PC board. Oh, it looks like they cheaped out on the screws. I got it hold in with 2 screws, but there's places for 6. I guess you don't need 6 to hold a little PC board like that in. And is that right? There's only 1 standoff on the display. Oh, that's not good. There's only 1 standoff where there should be 4, and that one is loose. Both the top and the bottom screw are loose on it. Ugh. This one was put together at 3 minutes to 5 on a Friday or something like that. That's just a standard 1602A 16 character by 2 line module. I mean, they're not, these don't cost $20, but at least I got this if all else fails. Oh, and there's an Atmel ATmega 48V microcontroller there. A couple, I'm gonna need a magnifying glass to see what these are, and I'll be right back. Okay, so these are TL072s, but the Texas Instruments logo on them looks really, really bad. So my bet is they're counterfeit parts. This is a boost regulator over here. Chenzing capacitors. I've never heard of those before. It must be a cousin to Wang Honglo or something like that. Okay, this is bugging me. I'm gonna have to take the board out and have a look at that. Now, in my research of this, I also found that those people who got really, really bad ones like this were able to make them work decently by replacing the op amps with genuine brand name parts. So that's an option we could look at. I mean, it wouldn't be hard to unsolder them at all and solder in some new ones. Just put a little bit of protective tape around there and have at it with a heat gun, or use the 2 soldering iron method. But that capacitor's a little close for that. We could always just snip the leads, clean up the pads, and solder new ones in place. These are about 50 cents, 75 cents each, even for the real ones. So they're cheap enough. Okay, let's tighten up. Look at that screw. That's just ridiculous. That is insane. And to me, it looks like these standoffs are higher than are required. Oh, hold on a second. I'll be back. Okay, sorry for that. I wonder if these standoffs might be too low. Doesn't look like it would hit anything. Maybe this capacitor. Is that the... No, it's taller than the capacitor. Because, the reason I say that is I noticed that when I was pulling it off there, if you go plug this LCD module in and you level it out, like if you did put in all 4, it's not wouldn't even be making contact with the contacts in here. And I think that's why they left that out. Now that I'm thinking about it, is that so they could push it down like this, and so the thing can make contact. So I mean, that's just is unbelievable. I mean, like if you look at it, it's a well laid out board. It looks like a nice board. It looks like somebody took some time to design it. So I'm thinking this is just a clone of something. Like that, at one time you could get these things, and at one time they were a decent little piece of hardware. But the clone market has just taken over. And just a little thing here. See at the base of that standoff there, I put in a 3mm nut and a little bit of Loctite to Loctite it all down. And I just put 2 of them in. I think that's plenty sufficient to hold that display. And another thing I want to update you on is that I sent a little note off to the supplier of this, and within 10 minutes I had my money back. Okay, so what I'm going to do here, I'm just going to poke around in here a little bit with the oscilloscope. So I've got the probe hooked up now, a 10x probe. And I'm just going to have a look around in here. That clip doesn't look like it's going to give me any fun today. So let me get the scope rolling here. There we go. Now I want to have a look at the output. This looks like an R2R ladder here. So I would say that if we put the probe right here, we're pretty much at the output of that R2R ladder. Now, okay, that doesn't look too bad. Believe it or not, I know you can see a lot of steps in it. So all you really need to do now is do some filtering based on the time between changes in voltage. And you can filter all that out and still have a very good sine wave. Now if we go over here to the inputs of these op amps, we can have a look. So it's 2 and 3. See the output here. Yeah, that's not so nice. Yeah, what about this one over here? What do we have coming out of this one? Oh, yeah, it's just keep getting worse. Yeah, so as you go down along the chain there, it definitely gets worse. It's basically what our output looks like. Yep. That's our final output there, is the pin 7 over here. But like I say, that signal coming off the digital to analog converter is actually pretty good. I mean, that's exactly what I would expect. So up to this point, we're getting something good. So maybe it's true that these op amps here are what are destroying everything. And I tried adjusting this little pot, but it doesn't really do anything. It It's a very, very small effect at some of the lower frequencies, but up at this frequency it does nothing. It certainly doesn't fix any of the problems. Yeah, that's really disappointing. That's really disappointing. But I think that I'll order in a couple of those operation amplifiers, and I'm going to try replacing them and see what happens then. All right, guys, as it stands right now, this is a big thumbs down for this. This is crazy crap. Absolute trash. I mean, okay, so I don't know what the chances are of getting a good one or one like this. I obviously didn't do well on that roll of the dice. But others apparently have, so I don't know if now the market is just flooded with these and that you're 99% chance of getting a piece of crap and only a 1% chance of getting a good one. It's up to you. Like I said, it was just over $20 Canadian to get it shipped to me. It's not worth it. It's not worth the tenth of that. But we'll see. Maybe it can redeem itself by replacing those operational amplifiers. Thanks for joining me today, guys. Definitely not recommended. Have a great day. We'll see you in the next video. Bye-bye.